Internet, welcome back. Today we're going to be looking at Lesson 11.1 Notes, Area of Parallelograms and Triangles. So the first thing that we're going to be looking at is area of a parallelogram. Now, area means the size of a two-dimensional shape. How much can you fill up a square or a rectangle or a circle? Those things are two-dimensional shapes. So if I were to draw a picture, let's say I have a rectangle, which is a two-dimensional shape, and basically I'm trying to figure out the area of this given figure by using a certain formula. And there are plenty of formulas. There are multiple shapes that we're going to be dealing in this course, and there are multiple formulas that we're going to be working with, okay? So that's the idea. I have my rectangle. That's my two-dimensional figure. How much space can I fill up this thing here, okay? So let's look at area of a parallelogram. And remember, parallelogram, if I have my figure here, it's a quadrilateral where opposite sides are parallel, hence the name parallelogram, and opposite sides are congruent. Okay, so let's take a look at this. The area of a parallelogram is the product of a base and its corresponding height. In other words, A is equal to BH, or the area is equal to base times the height. So to figure out, what's the base and what's the height, you have to know this rule. You're going to make a note here. The note that the base is always perpendicular to the height, meaning that those two segments will intersect at a 90-degree angle. So given this figure over here, that's my parallelogram, you have the base, you have the height, it creates that upside down T, so that means that those two segments intersect at a 90-degree angle. Okay? So let's take a look at example 1. It says, find the perimeter and area of each parallelogram. You may need to use Pythagorean theorem to figure out certain problems. And at this point, I assume that you already know how to use the Pythagorean theorem. So let's go ahead and do this to save some time. I'm going to write some triples, which we talked about back in Unit 8. So some triples that we need to know are 8, 15, 17, and 7, 24, 25. So what this means is that, okay, I have a squared plus b squared equals c squared for a right triangle. This is a, b, and c. So a squared plus b squared equals c squared, or 8 squared plus 15 squared is equal to 17 squared. And then for this one, you have a, b, and c. So 7 squared plus 24 squared is equal to 25 squared. So we're going to be using those triples to, answer some problems here, again, just to save some time. Here's A. I have my parallelogram. So since we can assume that this figure here is a parallelogram, then I can say that opposite sides are congruent. So if this is 10 inches, this has to be 10 inches as well. And if this here is 4 inches, that means that this segment over here is also 4 inches. So the perimeter is basically the sum of all the side lengths, the total distance around the figure. So I can just add up all the sides. Note that I have two 4s here, so 2 times 4, plus I have 2 10s, so plus 2 times 10. And that's going to equal to 28 inches. And yes, units do matter. It's so important that you understand your units now, because I have 10 inches plus 10 inches plus 4 inches plus 4 inches. It's just like combining like terms. You're adding, you're taking one-dimensional object and adding another one-dimensional object. So therefore, your unit should be the same. There should not be any exponents when you are writing your units. So it's just plain old 28 inches. So that's the perimeter, by the way. That's the perimeter. Let's go ahead and figure out the area. Well, the area is base times the height. So the area is base times the height. And remember what I said, the base will always be perpendicular to the height. So A is equal to 10 times 5. And that's going to be 50. And if you assume that this here is the base and this here is the height, well, your answer is still going to be right no matter what, but technically this is the base. Okay, so let's go ahead and write our units, because first of all, since I'm multiplying, first of all, this should be 10 inches times 5 inches. 10 times 5 is 50, and inches times inches, y'all, it's basically like this idea. X times x is equal to x squared. Inches times inches is equal to inch or square inches, or inches squared. So your answer should be 50 inches squared. Okay, 50 inches squared. So let me go ahead and highlight our two answers, and that's A. For B, I have a parallelogram. Remember, since this is a parallelogram, opposite sides are congruent. So if this is 21 centimeters, then this side length here is 21 centimeters. If this side length is 17 centimeters, then that means that this side length here is 17 centimeters, okay? So I can just add up all the sides here. So I have two 17s, so 2 17 centimeters plus 2 21 centimeters. That's going to be my perimeter. So my perimeter, if I were to put that all in my calculator, that's going to be 76 centimeters, okay? 76 centimeters. The area, well, the area is going to equal to base times the height. So note that this is my base, which is what? 21, the base of the figure, by the way. The base of the figure. So the base of the figure is 21 centimeters times the height. But note that we don't have the height here. We only have this triangle, this right triangle, with side lengths 8 and 17. So 8, 17, and this is a right triangle. So I have to use the Pythagorean theorem to figure out this missing side length. But I already have 8 and 17, so if I go back over here, 8, 15, 17. So the missing number, the height here is 15. So this here is 15 centimeters long. The height is 15 centimeters. So now that I figure out the height of the parallelogram, I can go ahead and plug that in. So I have 21 times 5. That is 21 times 15, which is 315 what? Centimeters squared. So these are your two answers. All right, let's take a look at C. I need to figure out the perimeter and area of the parallelogram, the solid lines here. The dashed lines will help us figure out, a certain part, but that's not included with the figure. This is what I'm trying to figure out, okay? So, okay, if this here is 23, then that means that this side length here has to be 23 feet. 23 feet, okay? And that's because it's a parallelogram, so opposite sides are congruent to each other. And then, well, if I'm trying to figure out the perimeter, well, I have to figure out this side length here and this side length here. And since it's a parallelogram, again, those two sides are congruent to each other. Opposite sides are congruent. But I don't know those two side lengths. I'm only given this right triangle over here, and we have 7 24. It's a right triangle. So that means that this side length here has to be what? 25. 25 feet here and 25 feet there. So I can go ahead and add up all the sides now. So P is equal to, I have two 23s, or 2 times 23 feet, plus 2 times 25 feet. So P is equal to 96 feet. 96 feet. And the area is equal to the base times the height. This is the base of the parallelogram itself. You don't include the 7 at all because it's this imaginary line here. So we're actually referring to this side length. It's 23 times its height, which is 24, right? So A is equal to 23 feet times 25 feet. So 23 times 25 is, oh, I'm sorry, I made a mistake. This should not be. This is 23 and the height is 24. So I should put 24 here. Okay, so 23 times 24 is 552 feet squared, because feet times feet is feet squared. All right, here we go. So example 2 says use special right triangles to find the missing dimensions and then find the area of each parallelogram. I don't need to find the perimeter at all. I'm just going to be finding the area. At this point, I assume that you know how to use special right triangles, so I'm just going to go through these problems quickly. So remember, we have a parallelogram. So that means that opposite sides are congruent. So if this side here is 17, that means that this side here is 17. So then, okay, we have this segment perpendicular to that segment. So I can go ahead and put 90 degrees here. Since this is 45, this is 90, that means that this angle here is 45 degrees. So then I can say, okay, I can set, since I'm only looking at this right triangle now, I can set 9 equals A, and I can set this side here, I can set that side to A as well. And then across from 90 degrees, this is going to be a root 2. So that means that, okay, well, A has to be 9. And then this side length here has to be 9 root 2. But I only need, because I'm only finding the area of this parallelogram here, A is equal to base times the height. This is the base. It's 17 yards, right? This whole thing here is 17 yards. So A equals 17 yards times the height, which is just, what, 9 yards. So A equals 17 times 9. That is 153. And then yards times yards is yards squared. And that's your answer. A equals 153 yards squared. All right, let's take a look at B together. Okay, so again, we can assume that this is a parallelogram. So opposite sides are congruent. So this is 32 meters. And these two sides are congruent. Note that these segments are perpendicular to each other. So I can go ahead and draw a 90-degree angle there. This is 30, this is 90. That means that this angle is 60. So I can say that across from 30 degrees, this is, this right triangle here is A. Across from 60 degrees, this side here is a root 3. And this, since it's across from 90 degrees, this side has to be 2a. So then I know that a is 12. That means that this side length here is 12 root 3 meters. Okay, so the height of the parallelogram here is 12 root 3. So I can just say, oh, a equals base times height. A equals the base, which is 32 meters, times the height, which is 12 root 3. 12 root 3 meters. So A equals 32 times 12. That is 384. And then we can't forget the root 3. So 384 root 3 meters squared. And that's your answer. All right, here we go. The next thing that I want to look at is this, the area of a triangle. So the area of a triangle is half the product of the base and its corresponding height. So here's my triangle. We use A equals 1/2 BH, or A equals BH over 2. And note that just like what we talked about at the beginning for parallelograms, the base and the height are perpendicular to each other. So here's my triangle. The base is perpendicular to the height. They intersect at a 90-degree angle. So if you're trying to figure out the area of a triangle, make sure that you're using one of these formulas here. They're basically the same thing. All right, here we go. We're going to find the perimeter and area of each triangle. So I don't want you to be fooled when you're looking at this picture. You're not trying to figure out this triangle. You're trying to figure out the figure that's has solid lines. So, okay, so let's go ahead and figure out what we need to do here. Number one, I have to find the perimeter. And I have this 41 inches, I have this 19 inches, and I have this side length here, which I don't know what that is. But as I can see, we have a right triangle with, if I'm just looking at it, individually, we have 27 inches, 30 inches. So what does this have to be? So I'm just going to have to apply Pythagorean theorem for this one. A squared plus B squared equals C squared. 27 squared plus 30 squared is equal to C squared. And this is going to be, okay, so 1629 is equal to C squared. I'm going to take the square root. Y'all, I don't want to use, I don't want to simplify this radical. It's too big. So we're just going to go ahead and say it's approximately, C is approximately 40.4 inches, because that's the unit we're dealing with. So that means that the side length here is 40.4 inches. 40.4 inches. Okay? So, gotta find the perimeter. I'm adding up all the sides. So P is equal to 19 plus 40.4 plus 41. Y'all, that's gonna be approximately 100.4 inches. And the area is 1/2 base times the height. So it's the base of the figure and also the height of that same figure. This is not the height. It has to be perpendicular to the base. So here's my base. This is my height. This side here has to match with whatever appears to the right or left. In this case, it's the right, so it's 30 inches. So A equals 1/2 of 19 times 30. So A equals 285 what? Inches squared. All right, here's B. I'm trying to figure out the area and perimeter of this triangle. So, first off, I have the base. I need the height. And perhaps I need to figure out the hypotenuse of this right triangle. Because, y'all, if this segment here, if we're looking at this, if this segment here is perpendicular to this segment, if this is 90, this has to be 90. Okay? So, what I'm trying to see here is that I need to work with this small right triangle first. So, if I can figure out the side length here, given that I have two side lengths, I can figure out what this is using Pythagorean theorem. So it's a squared plus b squared equals c squared. Remember, when you're doing the Pythagorean theorem, this is the hypotenuse. That's your c. And then you have 6 squared plus b squared equals 13 squared. So you get 36 plus b squared. That's equal to 169. Subtract both sides by 36. You get b squared equals 133. Take the square root. B is approximately 11.5. All right, so B is approximately 11.5. That's my height, actually. So 11.5 what centimeters? Okay, so now what do I have to do? I can figure out the area. Great, let's do that. So it's base times the height. The base of the triangle multiplied by the height of the triangle divided by 2. So A equals 1/2 times the base times the height. A equals 1/2 of 29 centimeters times the height, which is 11.5 centimeters. And that is going to be approximately 166.75 centimeters squared. 166.75 centimeters squared. Okay, so that's the area. What's the perimeter? So the perimeter is 29 plus 11.5. So 29 centimeters plus 11 centimeters plus this side here. And note that, okay, we have a right triangle. We have a right triangle. This is going to be my A, B, that's my C. Let's write, I'm going to put it over here. A squared plus B squared equals C squared. A is 29 squared plus 11.5 squared equals C squared. 29 squared is what? Here, I'm just going to go ahead and just jump right into it. This is going to be 974, which is equal to C squared. Take the square root. And C is approximately 31.2 what? Centimeters. So, this side length here, the hypotenuse of this right triangle is 31.2 centimeters. So then, okay, I have my base, I have the height, and I have the side length. To find the perimeter, I'm just adding up all those sides. So I can go ahead and finish this over here. So 29 centimeters plus 11 centimeters plus 31.2 centimeters, that will be approximately 71.7 centimeters. Okay? And since you're adding, or sorry, if you're taking a one-dimensional object and adding another one-dimensional object, the centimeters basically becomes the centimeter, if that makes sense, because you're not really going to include exponents whatsoever. Just think of this as, again, combining like terms. Okay? All right, here we go. This one says use area to find missing measures. So remember, here I have a triangle. It's A equals 1/2 base times, A equals 1/2 base times height. Note that the area is already given, so I can just replace A with 357. All right, so this is where I have the area, which is 357. And then what I'm going to do is I have 1/2. I'm going to multiply that by my base, which is 34. And then multiply that by x, which is the height. And then 1/2 of 34 is 17. So 17 times x, that's 17x. Divide both sides by 17. 357. 357 divided by 17, that's 21. So 21 is equal to x, so it's 21 inches. That's your answer. That's the height. Okay, all right, here we go. B, find x. A is equal to 148 meters squared. This is a parallelogram. So A equals base times the height. The area is given, it's 148. Which is equal to the base, which is 8, times the height, that's x. So 148 equals 8x, divide both sides by 8 here. X equals 18.5 meters. And that is your answer. That's the height of the parallelogram. So 18.5 meters. Okay? All right, actually two more things here. Heron's formula. It relates the lengths of the sides of a triangle to the area of the triangle in case you don't have the height of a triangle. This is so important because here you're given a triangle and you're not given the height. So let's go ahead and make a note. Not given the height of a triangle, use Heron's. Heron's formula is this. A equals the square root of S times the quantity S minus A times the quantity S minus B times the quantity S minus C, where A, B, and C are the side lengths, and S is the semi-perimeter. So the perimeter is the total distance around the figure, and semi means half of that, right? So semi-perimeter, which is S equals A plus B plus C all over 2. Example 5. Find the area of a triangle with side lengths 12 meters, 16 meters, 22 meters using Heron's formula. Again, I have a triangle. I don't have the height. I have to use this formula. So I need to, when I'm doing this problem, the first thing that I need to do is figure out what my A, B, and C are. This is A, this is B, and this is C. So what's this semi-perimeter? It's all the side lengths added divided by 2. So S equals 12 plus 16 plus 22 all over 2. So your semi-perimeter is 25. Okay? So I can go ahead and replace all the S's with 25. And then replace A, B, and C as well. So A equals the square root of 25 times 25 minus my 12 times 25 minus the 16 times 25 minus 22. And I can go ahead and put this in my calculator. Exactly. And that should be approximately 93.7 inches squared. And y'all, if you have a very, very large square root, I don't want you to simplify the radical unless it tells you to give the exact answer. But an approximate would be fine and a lot easier, okay? Example 6. The base of a triangle is twice its height. If the area of a triangle is 49 square feet, find its base and the height. All right, so first of all, we're dealing with a triangle. So your formula, because it says area of triangle, A is equal to 1/2 base times the height. And it says over here, the base of a triangle is twice its height. Y'all, do we even know what the height is? It doesn't say it at all, right? I'm looking over here. I don't see, how long the height is. That means that is our unknown. The height is our unknown, which we'll call x. And the base is twice the height. So I can write b equals twice the height, or 2x. And the area is given, that's 49. So let's go ahead and just plug everything in. This is 49. That's equal to 1/2 of x times 2x. So 49 is equal to, let's do this. 1/2 of 2x is just x. And then you're going to multiply that by this x. So 49 equals x squared. Take the square root. Take the square root. So x is equal to plus or minus 7. But in this context, we need the positive because we're dealing with shape. So x equals 7. So the height is 7. The height is 7, and the base is 14. And there you have it.